Okay, good day everyone. So, yeah, welcome to the live session of Advanced Programming course. And the topic for today's video is about reviewing the quiz and also to prepare for the upcoming midterm exam. So, welcome to any of you who are viewing this right now, and for those who are watching this later, well, welcome. And probably it's better to make some notes because I will provide you with some pointers regarding um, the upcoming midterm exam. So, without further ado, let's begin. So, the agenda first, we will see the solution for the quiz number 6, which is about 12 factors application methodology, and then continue to the preparation for the midterm exam, where I will list the topics that will be covered during the exam and also the procedures for the written and also the interview exams. So let's start from the quiz number 6. Before I begin, let me prepare the problem set document first. Okay, and then right. I think I need to turn the music volume down. Yep, that's better. And I think it's better to share the whole screen. Cool. Now, here on the screen, I show the problem set that is used during the actual quiz session this afternoon. And yeah, the problem set was about 12 factors app methodology, which we have covered during the synchronization in the beginning of the week. And yeah, the problem comprises of 4 plus 1 questions, 4 question plus 1 bonus. And it's about this code example that showcase how to use Spring Data, REST, and GPA. And it can be accessed on the given URL. So you can try to open it through your web browser. And while the details of the code example is interesting, especially how Spring Data, REST, and GPA provided so many functionality that lets us to create a REST-based web service by little amount of code. The main focus of this quiz is regarding the compliance of the code example with 12 factors app methodology. And to work on the quiz, actually it is enough to work on the quiz just based on the snippets provided in the document. However, if you are curious on the entire source code, then you can access the GitLab repository. And here we have the snippets for the application configuration. There are 3 of them. First is the default configuration, which is written in the application.properties file. And then there is the second configuration written in the application.ci.properties. And the third one is the application-heroku.properties. And it still contains the configuration for the application. What makes them different are the actual problem in the quiz. We will see about it later. And then we have the definition of the prog file. Okay, let me change the view. Now, the prog file itself is you could say it as the configuration file read by Heroku to determine what kind of process that should be run when the dyno run the application. So in the prog file, there is one process called web, and this process will execute the following command: java -d server.port equal to the port variable, and so on. So later on, when the application is deployed to Heroku, and the Heroku will build the application and run the build jar file in a dyno, the dyno will execute this statement, whatever declared in the prog file. And then, lastly, the last snippet was taken from the .gitlab-ci.yaml file. It contains the CI jobs used to build, test, and deploy the application. But the main concern for this quiz is the test job. And the test job itself runs during test phase in the CI pipeline. And it includes another service called Postgres. And this service called Postgres based on a container image that provide PostgreSQL database. So when this job is run on CI server, the CI server will run the test job in a container, and also it will spawn another container that runs PostgreSQL database, and both container can communicate. And then after that, we have variables that contain the environment variables assigned to the container that runs the job. And the environment variables here will be assigned to the container that runs the CI job, and also to the service container that runs PostgreSQL database. That's why we have these variables Postgres underscore DB user and password, because we need to define the name of database, its user and password, when we are running the database as container. And also we have the remaining variable spring underscore data source underscore URL. This variable actually override the same properties defined in the application properties. So even though we already have application properties built into the jar file, we can still override the properties by using several mechanisms such as environment variables, and also we can override anything that we have written in the application properties files by using the -d argument when we are invoking Java command. And now we also have this script block that contain the commands that will be executed in the test job. So it will execute Cradle check, which will run the test runner, and also the test where the test runner will execute the test suite. And we can see here the argument contain spring.profiles.active equal CI. It tells the Gradle that the project should be run with the following properties. The Spring Profiles active properties is set to CI. That means when running the test runner that executes the test suite, the Spring Boot app will use the CI configuration profile alongside with the default configuration. And then the second command here is simply return the content of this HTML file and match the string that contain the pattern total, because in the code coverage capture configuration, the GitLab requires the string that contains total string followed by some percentage. And by using a regular expression, the percentage will be obtained and can be displayed via the pipeline pages that rendered in the README file. So let's begin from the first problem. What's the purpose of application.properties file? Well, if I follow my slides here, application properties provides runtime configuration to the application, and as I mentioned before, it can also be overridden through other mechanism. You can define the same property using environment variable in the operating system or by using the GVM system property. And you can learn more about this by reading the reference documentation, specifically at chapter 4.2 and 4.3, and also the appendix. So what's the content of that chapter? So here I have the actual PDF version of the reference. Because based on my experience, if I have to look for Spring related documentation, any result that come up on the search engine, whether using Google or DuckDuckGo, usually it is not the actual documentation provided by Spring framework. It usually the top result usually referring to some tutorials or articles, and probably those articles or tutorials are already outdated. So yeah, I tried to have a local copy of Spring Boot documentation. So that I know where if I have to look if I have to look something from the Spring documentation, I can just load it locally instead of googling it or searching it via search engine. So which chapter that I mentioned? 4.2. Externalized configuration. Yeah, the nitty-gritty details are explained in the documentation. But my focus here, I would like to point you, all the viewers, to this particular section. So, if we have a Spring Boot based application, the properties have certain order that dictates the application of the property. So for example here, if we already have application.properties file, then any properties that defined in the application properties file will be loaded first. And then if we have the same properties in the operating system's environment variable, then the Spring Boot application will use the property defined in the environment variables instead of the property in the application.properties file. So if we can override the property that already defined in the application.properties files. And as we look down to the next what do you call it, to the next items, the source of the property values, the lower items will have precedence over the item above. So let's say if you have environment variable and also you set the command line arguments, then the value that will be used, that will take the priority, is the value that you pass through the command line arguments. So let's say we have this kind of scenario. In the application properties, you have this property data source user. Let's say the user is example. And then in the environment variable, you have Spring data source user. You have the same property, and then you give it a name foo. So in this first case, if you try to execute the application.jar, let's say the name of your application is application.jar, then the actual Spring data source user will contain foo because the properties file is overridden by the environment variables. However, suppose that we have this Spring data source dot user bar -jar application.jar. The actual value of Spring data source user will be bar, because according to the order described in the documentation, the command line arguments take more precedence than the environment variables. So the example is overridden by foo, and then the foo is overridden by bar. Hence, the actual value of string data source user property is bar in this case. And then, what's the connection of these property files with profiles? Okay. Profile is, you could say that a profile is a set of application configuration. So by default, if we only have application.properties, our application have the default configuration, the default profile. However, we can also have multiple configuration for the same application. For instance, in the given code example, the application needs to have different configuration when run locally and when run on Heroku. Therefore, we have two application property files. The first one is the default. Here, this is the default properties file. And then the second application property is the application-heroku.properties, where it contains the property and the values, some of the values are assigned through environment variables that set by Heroku's dyno or by Heroku. So here we can see that the actual URL is based on the environment variable named gdbc underscore database underscore URL that's set by Heroku. And in Spring Boot, the name of profile is determined from the word before the extension. That's kind of weird to say it. Well, application properties is the default profile. And then if we have an application dash followed by dash symbol and then a word or a phrase, then the phrase itself is the name of the profile. So in this example, if we have application dash CI and application dash Heroku, that means we have CI profile and Heroku profile. And yeah, what else? The common application properties appendix here only lists all possible properties that can be written in application.properties file. Okay. So the next problem is about let's see. The activation criteria of each application properties variants. Okay. So how to activate this profile? Okay, I already explained this. So we have 3 profiles. And to activate one of those profiles, we can set the spring.profiles.active property through the arguments or through the environment variable. And to activate CI, the CI profile is activated when running the test job on CI server. So we can see here in the GitLab CI configuration, we explicitly ask Gradle to set the properties to CI. So when the test runner is executed, the Spring Boot app run by the test runner connects to the PostgreSQL database that is running alongside with the container that runs the Spring Boot application. So the information required to connect to the database is given through the environment variables instead of from the application property file. And in case of Heroku, we need to see the prog file. So in the prog file, we explicitly ask Heroku to pass the following arguments. First, the server port. The server port needs to be assigned with any value contained in the environment variable named port. And then the second argument is the spring.profiles.active property is set to Heroku. And then the third argument here to pass anything inside the Java underscore OPTS environment variable, because the Heroku dyno that runs Java application already have some custom options that needs to be passed into the JVM that runs a Java application. This is only to make it explicit. There will be some Java options set by the Heroku's dyno that needs to be passed down into the JVM. So yeah, this one, the Spring that provides that active equal to Heroku means the application needs to use the Heroku profile. Now, these profiles will activate some in a way similar to how inheritance works. So if we have all of these application.properties files in the same jar file, then Spring Boot will use the default and will override it by any values declared in the selected profile. So for example, here we have the default configuration where the data source is using H2 database. However, since we explicitly require to use Heroku profile on Heroku, then these properties will be overridden by values written in the Heroku's profile. So previously, for example, the URL was gdbc h2 mem and so on. Then on Heroku, it will be replaced by this $sign curly brace gdbc underscore database underscore URL, which in turn will read the value from the environment variable. And similar things happen to the username and password variables. Okay, so what is the next problem? Log messages. So if we try to inspect the log messages in the deployed application, you might see these log messages. At first, the application is running at some port, for example, port 46023. Then at some time in the future, the port changed to another value. So the question is, how Heroku able to change the port used to serve the application? Even though, if we take a look at the application to properties, we actually have defined a port 8080 because that is the port that we usually use when we are developing locally in our own computer. Well, you already noticed it before. In the prog file, we override the server.port property by making the value read from the environment variable named port. And the environment variable port will contain the port number set by Heroku. So when Heroku receive the request to your application and the dyno that containing your application is currently down, Heroku will start the dyno and allocate a port number, and that port number, the number is set to the environment variable called port. And When the dyno read the prog file, it will, as part of the process creation, the Java command read the server.port argument and then see that the value is read from the environment variable. Therefore, when the process starting up the Spring Boot application, it passed down the port number to Spring Boot application, specifically to the Tomcat server embedded in the Spring Boot application, and make it run on port that is defined from the operating system's environment variable. Yep, that's roughly what I just said before. Now, next question is about AdvProg parity. So, what is it about? Well, in short, it's about making the development environment as similar as possible to the production environment. So we have development environment. Usually this is referring to the computer that we use to develop our application. And then we also have production environment. This is usually referring to the environment where the application will run and will be used by clients. And to achieve this DevProg parity, well, not achieving, but rather we try to minimize the parity. Is that the correct English? I mean, yeah. We try to minimize the parity or the difference between the development environment and production environment. And the level of sameness of both environments can be what do you call it? Can be achieved in varying level. Maybe in systems level, the difference are minimal. For instance, both the development environment and production environment are using the same hardware and also the same operating system. Or in the operating system level, both the development environment and production environment use the same operating system, but maybe the machines are different. So the dev environment is using a PC with AMD processors, but then on the production environment, it uses Dell server with Intel CPUs. And then we can also have application level parity, where this usually referring to the dependencies used to build and run the application. For example, both in dev and production, they use the same packages. So the dev using Java 15, and then the production is also using Java 15. And the variant of Java 15, both are using the build from Adobe OpenJDK projects. And the libraries used are also the same version. So the development environment using Spring Boot 2.4.3, and the production environment is also expected to run Spring Boot version 2.4.3 as well. So if we try to review the current state of the example, we can have this following matrix. We can see that the application dependencies are the same across the environments. and this can be seen in the build.gradle file. Let me check it. So here we have the list of dependencies used by the project in the build.gradle file. We can see here we have numbers of dependencies such as the actuator, Spring Boot Starter, data GPA, REST, Liquibase for data migration, Project Lombok to reduce boilerplate codes, and there are also dependencies that only included during runtime of the application, like the H2 database and also the connector driver PostgreSQL. And also the Gradle plugins used are also defined in the build Gradle, like what is the version of Spring Boot version here used in the project. The project uses 2.4.4, and then it also using the Spring Dependency Management plugin version 1.0.11, and I suspect the actual dependency version resolution, the process to actually figuring out the version used by each library used in the framework, is done by this plugin. But yeah, I need to refer to the documentation and probably need to review the codes as well. But yeah, this is only educated guess. And there is also Java plugin, although we didn't mention the version, similar to Jacoco as well. To be safe, usually the best practice is to mention the version number as well, especially if we want to ensure the repeatability of our build in the future. Because it is possible that 1 year or 2 years after the development, many things have changed. So let's say the Jacoco plugin version this year is, let's say, pick a number, version 1 for example, and then 2 years in the future the version already incremented to version 5, and turns out if we try to run the same code in the future, it is possible that our build will fail because there is an incompatibility in the version. So maybe in the future, the future version of Jacoco is not able to run with this project. So that's why it is important to mention the version as well if we are declaring dependencies in the project. At some cases, this is a bit of out of topic. I remember that one student in the lab that is currently doing his thesis work, he had to go through several number of commits to figure out which version of a framework that was used by his predecessor, the one that developed the work that used as the basis or as the base for the students' thesis work this year. Because his predecessor didn't mention the actual version of framework that is used during his thesis work few years ago. So yeah, I suspect the process probably took few hours just to going through each commit and checking whether the build framework compatible with the application that the student built. Okay, so back to the issue of DevProg parity. Application dependencies are basically the same. That's already good. And then the issues come up in the database. The local development is using H2 in-memory database, while the continuous integration and Heroku, which is the production, are using PostgreSQL 13. Well, according to the DevProg parity factor, the recommended way of development here is to use to reduce variation across environments. So if in the end the application will use PostgreSQL 13, then make sure the local development on on each developer in the development team are using PostgreSQL 13 as well. Because who knows, there might be some compatibility issues that might not detected if the developers are using the different database. Well, to put it short, try to reduce variation across environments, including the database used during development and during production. So the recommendation here is ensure the database are using Postgre 13 across every environments. And then we also have system-related dependencies, such as the available Java version running in the computer, and also system packages like the SSL library or HTTP library and so forth. This one is a bit hard to standardize, or what do you call it, to make it uniform across environments. Well, on CI and Heroku, at least both are using container technologies that contain all the required system dependencies in a container image or build pack. So that issue is already resolved actually if using container technology, or if we are using the traditional approach, if we could have a dedicated server where the system packages of the dedicated server for CI and production are actually the same packages. So we have the same set of system packages installed both on CI and Heroku, and ideally on the development team's machine, they are also using the same set of system packages. But the reality, well, it's a bit harder to ensure the sameness of system packages in local development environment. For example, if I use Windows, and probably my Windows configurations are different from yours. Let's see. Yeah, for example, if I try to list all of the environment variables set in my Windows, you can see that I have PowerShell 7, Ruby 2.7, and then Adobe OpenJDK 15, Pandoc, Liquibase, Python 3.9, and so on. Your Windows could be different. Maybe you still use PowerShell version 6, you don't have Ruby, and then you probably are not using Node.js or not using Chocolatey, and that's just one part that's can varying across local development environments. And it could get worse if the OS is different. Yeah, we can move on to the next item, which is OS, the operating system. Well, I use Windows, and you can see in Windows, if we want to, for example, echo or print out the value of an environment variable, we use percent sign. Okay, wait, wait a minute, or is it in command prompt? Yeah, why in the PowerShell doesn't work? Okay, so in the command prompt, we can use echo percent the name of variable, then closed by a percent sign to print out the value of environment variable. But in Linux, we use $sign and then name of the variable. So in terms of development environment, OS can be an issue actually. For example, if the script is written for Windows, then it might not working if it is executed on Linux, or vice versa. Sometimes a line ending format could be an issue as well if we have a team with varying operating system. Okay, let me open Google. Line ending format. Yeah, let's just open Wikipedia. Windows uses CRLF, special characters, to signify a line ending. Meanwhile, on Unix-based systems like Linux, Mac OS, and also your Android actually, they use LF, special character, to signify a line ending. And at some programming language that might be sensitive to this variation, it could decide whether this code can be compiled or not. So probably the code that is written using Unix-based operating system might not work when compiled in Windows-based system, only due to the variation of the line ending format. So is it there? Yeah. So in order to ensure the sameness, or to ensure all of the development team using the same line ending format, it is usually recommended to set the text editor or IDE to use the same line ending. One way to enforce it by using editor config. Some modern IDE or text editors support this editor config file, where we can configure the behavior of the text editors. So in the editor config provided in the example here, we explicitly say that please use LF as end of line. So if this project is opened by any text editor or IDE that supports editor config, it automatically configures the text editor component to use LF symbol as end of line symbol. So if I use Windows here, and my text editor will always use LF when opening this project. And then regarding OS, the CI server, well, to be more specific, the container that runs the CI jobs, the test job, is using Debian-based OS distribution. And Debian-based distribution usually referring to Debian, Ubuntu, Linux Mint, and also other Debian variant that might I forgot because some distros are based on Debian. One of them is Heroku. And then we have Heroku Stack. And Heroku Stack that runs the Dino is actually using Ubuntu 20.04. So if I have to make my local development environment similar to the environment used on Heroku, ideally I should use Ubuntu as well. But how? I use Windows. Well, don't forget, we now have virtualization. Actually, we can run Ubuntu inside Windows. Or for some of you that prefer dual booting, I remember one of the TA is actually using dual boot on his laptop, so he installed both Windows and Ubuntu in his laptop. You can also do that, so you can have two operating systems running in your machine. And lastly, we have infrastructure. Usually the local development only using single PC or single computer. That is not a problem. But later on the CI server and also on the actual production, especially in the case of Heroku, the infrastructure could be so much different. So on CI server, the application will use two containers. The first container will run the application, and then the second one is running the database while the test job is executed. However, later on on the production, if you are using Heroku, your application will run on a dyno, and that dyno could be said that the dyno is load balancer. So the dyno will have another, you could say, a server or a dyno as well in front of it that functions as reverse proxy or load balancer. And that reverse proxy or load balancer will assign it to a public facing domain. So any request that coming up to your application will be handled by this reverse proxy or load balancer dyno first, and then that request then will be delegated to the dyno that is running your actual application. So that's why if you try to scale up your application by increasing the number of processes, you don't have to create another domain, or the Heroku doesn't need to create another domain, because every request will be handled by this load balancer or reverse proxy, and they will keep maintain the records of dynos that are running your application. If you only have one dyno, then the request will be directed to that one dyno. But then if you have, for example, 10 dynos running the same application, then the load balancer will decide which dyno that will handle a request coming up to your application. How the load balancer decide the dyno could be, well, could be assigned randomly or by using heuristic like round robin. Yeah, it depends on how the load balancer is implemented. So here we have the ideal situation. So we have the same application dependencies, we have the same database, we have the same OS operating system, and if possible, we could also have the same system dependencies. Although this can be hard to achieve because yeah, who knows whatever that you have installed in your own machine. And in terms of the infrastructure, this one could be the hardest thing uh, to fix, I guess. Because do you have because well, if we want to have the similar infrastructure as Heroku, that means we have to have the same machines. Well, if we take it like it in that way, then yes, we need to have the same machines as Heroku, but that is not feasible, right? So what can we be done is to approximate the production environment. This can be done by using container technology and also or virtualization actually, yeah. So by using virtualization and also container, we can sort of making the similar setup as the production environment in our own local development environment. But yeah, um, virtualization probably discussed in the operating system course, right? And container, well, we will have the um, we will discuss about that after the midterm exam. So yeah, stay tuned. And then on the issues of the parity between development and production, we could also have issues with variation of development tools used by the development team. Because yeah, some might prefer an IDE or a text editor over another. For example, as text editor, I prefer to use VI over anything else. So if I have to maintain a server, usually one thing that I usually do is to install vim or NeoVim, the newer version of it, the newer version of Vim, instead of using Nano, because I already accustomed to typing using VI instead of using regular text editor. Even if I have to use IDE such as IntelliJ or modern text editor like Visual Studio Code, one thing that I usually install first is the VI plugin. So I install VI plugin so that I can navigate in the text editor using VI key binding that I'm familiar with. And yeah, a developer can be highly opinionated on his or her choice of tools. Like myself, I use VI as my text editor. As for operating system, I don't really have any preference actually. I usually use Windows, but I can use Linux as well if I have to. But yeah, some people took it to the extreme, like some Arch Linux users, and also one of the well, you could say one of the leading person in open source world is actually the head of Emacs Church. Well, you can see the video later when you um review the slide deck in your own time. So the development tools may vary, but make sure the resulting product is the same. So that's why we have continuous build and integration in place. So even though the developers are using various tools to build the software, make sure the end result is the same and use it as the source of ground truth for for testing and delivering the product later to the customer. Is that it? Yeah. Now the bonus. Well, I already mentioned how is it done just now when I was discussing about load balancer. But yeah, try to recall how client-server architecture works in web application. Usually we have this abstraction where we have client, usually represents the web browser, and also we have server that contain the web application that we are trying to use via our web browser. The question is it that really simple? I mean, is it that simple where we only have this client send some messages to the server and then the server will send back responses back to the client? Is it that simple? Well, from you will say the 50,000 feet view, it is that simple actually. But if we try to dig down to the lower level, it is actually more complicated than that. And the keywords here involved in the process usually will have reverse proxy, load balancer, and some scaling process happen in the you could say the private cloud or the internal network where the application is hosted. But yeah, since this is a bonus, try to what do you call it? To look it up on your own. And if you want, we can also have discussion about this if you want to discuss about this through the office hour. Okay, so we reached the next part, which is about the midterm exam preparation. So the topics are as follows. First, the topic will include Git. So regarding Git, well, my tips is familiarize yourself with Git commands on CLI. So maybe during the interview exam, you will be asked to create a new Git repository from scratch, and I have to watch that process through the screen share. Or maybe in the written exam, there will be some questions regarding the output of particular Git command. And then the next topic is about refactoring. And I expect that if you are given a smelly code, you know why it is considered as code smells, and you should know how to fix it by applying some refactoring techniques. And then the topic will cover, the midterm exam will cover unit testing. So try to practice your unit test writing skill. Try to review your programming foundations to code examples and try to write unit tests to test the code. And then Sonar Cube. make sure you are able to set up a CI job that runs Sonar Scanner and view the analysis results on Sonar Cube. Heroku, well, you know what to do, especially if you have passed web design and programming course. I assume if you're already past web design and programming course, you should be able to deploy an application to Heroku. Concurrency, well, it has so much to cover, but I can summarize it to two key phrases: critical section and race condition. So yeah, try to focus on that two subjects. Asynchronous programming, well, make sure you know how to use future, executor, and also completable future classes. And then regarding performance and monitoring, you need to know how to measure a runtime of a function call, and then also to display it as log messages or as a graph on Grafana. So maybe I will need to ask you to run a Prometheus and Grafana in your own laptop or PC, and then try to obtain metrics from a locally running Java application. And then 12 factors app, given a running code example, you need to be able to assess the compliance to the 12 factors. So that's the list of topics that will be covered by the exam. And the exam will comprise of two parts. The first one is the written exam. It will be similar to quizzes. It will contain multiple choices, short answer, and also essays. And it is scheduled on 16 April 2021, so please be prepared. Oh yeah, one more thing. If you require extra tutorial or assistance from the TAs, please ask your TA. They can allocate their schedule to have a consultation session with you all. And then the interview part. So I already allocated some open schedules, and please book a schedule no later than 30 April 2021. And you can check the available schedules on Google Calendar. You can click this if you open the slides using PDF reader. So let's see how it works. Wait a minute. Okay, I think I need to turn off the display capture for a moment. Then, wait a minute. Okay. Display capture. Is it possible to? No. Oh, I need to clip it. Crop. So 200 pixels or 100. I think 100 is okay. Yep. So here I am displaying the Google Calendar view of my UI account. So my UI account already have some slots available starting from 12 April. So in 12 April there are 4 slots starting from 8 p.m. until 10 p.m. Then from 13th April the slot started from 9 p.m. because yeah, Maybe there are some of you who are usually what do you call it? Do Tarawih prayer for the first day of Ramadan. So yeah, so from the beginning of Ramadan, all of the interview exam begins at 9 p.m. instead of 8 p.m. So as you can see here, there are several slots, and let's say that I want to have the exam on Thursday on 9 p.m. So I click it, and then assuming your Google account is using your proper name, it will be automatically the title of the appointment will include your name here. So I immediately know who are going to have their interview exam with me. But if your Google account is not using your proper name, well, please help me by putting your actual name there. Okay. Okay, let's say that I book this schedule. Now it is not there. The schedule is already taken, so it doesn't show up there. And then from my own personal calendar, you can check here. Then Google will allocate a Google Meet room automatically, so please join the Google Meet at the time of your appointment. So let me delete it because yeah, that's just to demonstrate how to book a schedule. Okay, so now I need to refresh this. Yep, it's there. So I already freed up the appointment slot that just booked for demonstration just now. And yeah, I need to restore the setting of the stream. Yep. So the interview exam will have this kind of arrangement where the first 5 minutes will be used to introduce the problem set. So for example, at a course that I taught last semester, one of the problem set was about developing a backend for an online game. So yeah, I introduced the problem and also the API that should be supported by this backend. And then later on, the students are required to create the test cases to test the API. So that was one example of my interview exam that I used in last semester when I taught software quality assurance course last semester. And then the next 10 minutes is to work on the problem set with the camera and share screen enabled, because yeah, I need to see how you progress through the work. And then the last 10 minutes will be used for question and answers. And yeah, here we are, the last part of the video. Some reminders. it is your choice to attend or not attend the exam. um, because yeah, um, I remember that one last semester, one of the student uh, choose to didn't take part of the interview exam, and that is okay with me. And then please utilize the available office hours allocated by the TAs and also lecturer, which is me, to ask or and review the course materials. Because I feel the utilization of office hours is pretty lacking until now. From the beginning of the semester until now, there is only one student that arranged an office hour with me. So yeah, please, what do you call it? If you have some questions or doubts with the course materials, um, the TAs and lecturer are there, and please utilize them by asking questions. And also one reminder, though we are still far away from the final exam period, but this I need to tell this from now. The interview exam schedules during the final exam period will be tightly packed during the actual final exam period. So because we only have, well, not you all, but yeah, actually me as the lecturer only have 1 week to finalize the grade. Because 1 week after the final exam period ends, the any grades that achieved by you all needs to be submitted to SIAC. So yeah, I only have 1 week to compile all of the grades and submit it to SIAC. So that's that. Um, the time frame is pretty limited during the final exam period, so um, yeah, please be prepared to allocate your nights during final exam period to have interview exam. And why I put this twice? Okay, that's all from me. Um, I think I can conclude the stream now. So thank you for watching, and I'll see you later. Bye bye.